Okay, so in this video, I'm going to show you how to do a dilation. It's going to be a basic one because later on in our book, we're going to see dilations again. So here it is. Um, so what is a dilation? So let's go ahead and do the definition of that. Dilation. So it is a transformation. It is a transformation that changes the size. So that's important. Changes the size, okay, of a figure, but not its shape by a scale factor. So as you remember, the transformations that we saw last class, it was translation, rotations, and reflections. Those keep the same size, but this one makes the shape go be either bigger than the original or smaller. And that is because of the scale factor. So scale factor, we use the letter K. So if K, the scale factor, is less than 1, we say we have a reduction. Now, if K is greater than 1, we say it is an enlargement. Now, if you think about it, if K is equal to 1, you're not doing really anything because the shape, the figure, it's exactly the same. You're not making it bigger, you're not making it smaller. So it has to be less than 1 or greater than 1. Okay? So the rule for this, let's say you have the point x comma y, all you have to do is multiply every x by the scale factor and multiply every y by the scale factor. So it's going to give you a new point. So a quick example, let's say k is equal to 2, and let's say the point is 1 comma 3. So then move it up a little bit. So then what we have to do is, well, the scale factor is 2, so we do 2 times 1 and then 2 times 3. So the new point is going to be 2 comma 6. Okay? All right, so that is a quick example. So now let's actually do a real example where we have to plot points and apply the dilation. So let's say so let's see example number 1. So let's say I am giving a rectangle with the following coordinates. So A is at 0, 6. B is at 4, 6. And C is at 4, 0. And finally, D is at the origin. And then the scale factor is equal to 1/2. Well, at this point, you have to think and be like, okay, well, K is less than 1/2. So that means it's less than 1. Therefore, we are going to have a reduction. The picture is going to be smaller. Okay, so let's go ahead and do another example. So just remember that this one is similar to that one. All I did is I took the point A and multiply every x and every y by a factor of 1/2. So half of 0 is 0, half of 6 is 3, half of 4 is 2, half of 6 is 3. And that's how you do it. Okay, so let me give you another example. So let's say I have a triangle this time. So triangle is example 2. And then we have a triangle with the following coordinates. So let's say A is at 1, 1, B is at 1, 3, and C is at 2, 3, and the scale factor is equal to 2. Well, Scale factor is bigger than 2. So now it's bigger than 1. So that means we're going to have an enlargement, and we're going to see that. Okay, so I'm going to use pretty much the first quadrant because it's going to get bigger. So I'm going to plot those points. 1, 1, that's A. Then 1, 3. 1, 2, 3, that's B. And then C is going to be at 2, 3. So there's C. We have a small right triangle. Now, if I'm going to apply my scale factor, I know A prime is going to be, well, 1 times 2 is 2. 1 times 2 is 2 again. Now, B prime is going to be 1 times 2 is 2. 3 times 2, you get 6. Now, C prime is 2 times 2, it's 4. And 3 times 2 is 6. So as you can see already, this point is bigger than that one. And same for that one, same for that one. So let's go ahead and plot them. So you go for A prime, you go to 2, 2. So it's right here. Here's A prime. Now B is at 2, 6. So it's 2, 3, 4, 5, 6. So here's B prime. And C is at 4, 6. It's 3, 4. And here we go. And as you can see, the picture, it was enlarged from this one to that one. And again, we say triangle ABC is similar to triangle A prime, B prime, C prime. Okay, they are similar because they have the same shape, but the size is different. And remember that congruent means same size, same shape. And this one is only the same shape. Okay. All right, practice, people, practice.